Hi everyone, I am Aditya Narayanana or 0x0elliot, and today I'm here to talk about the problem of computers and randomness. So a little bit about myself. I am a software developer and a security enthusiast. I'm currently pursuing my BTech in CSE from Bennett University. I like to make and contribute to open source software in my free time, and I am not really an expert on this topic of randomness. It's something that requires PhDs and PhDs, but I just happen to walk into a couple of nerds speaking about randomness, and that's how the spark started, and that's how I started researching on it, and that's me. Thanks, Atomic, for putting that as the official picture. Anyways, so here is the problem statement. Computers are deterministic machines, okay? So if you want your computer to add 1 with 1, it will give you 2, right? It's efficient at doing exactly what you ask it to do, but at the same time, it's not smart enough to come up with the things on its own. But then how the heck are we able to generate OTPs randomly when we require it, or cryptographic keys when we require it? So this is what I want to address in this talk about how we move forward. For reference, the spoiler alert about a lot of things that are going to come. I want you to think of coming up with randomness with respect to a function, a mathematical function itself. So let me lay down some ground rules. First of all, we're going to use Python for reference because it's easier to read, and everyone in the security community must have used Python at one place or the other. The other ground rule that I want to lay down is that when I say random here, I don't really mean random. It's actually pseudo-randomness, because whenever it comes to computers, you cannot actually come up with pure randomness, right? Well, if you think about it, nothing is truly random, but let's not go there. So the talk is more about pseudo-randomness rather than randomness. Yeah, so let's begin. Finding a solution to the problem that I laid down. I would have wanted you guys to pull out your terminals if you guys were in front of me. But really, think about it. How would you come up with one function which would output a random number every time you run it? It's a great question that would spark your curiosity in this topic. To the panel, do you guys have any guesses? Make light guesses, okay?
I mean, if I was going to put something random, we all know the correct way of doing it. Let's try to find a way that's a little bit more creative.
Yeah.
I don't know. The power drainage from a CPU. Like
Okay.
a CPU is going to do a various number of operations per second.
I like
and
that. That's a good idea. That's a good idea. Good
either
job, Atomic.
number of threads or power drainage or things like that. That could be interesting. What else? Problem is that it's not a compound value, right? So you're going to get something in a range that is somewhat predictable, depending on. I don't know. Eden, you have any ideas?
Okay.
If
Does
I could
anyone
figure
want
out.
to join me?
So sorry.
It's fine. Continue.
We're talking about something random that I don't know. Yeah, I have to remember to unmute my mic sometimes, so I'm sorry if there's a delay in when I'm speaking, but something random. No, I've got nothing. I was actually just about to whip out my code editor and see if I can generate something without using a pre-written function. So I'll get back to you in chat when I finish up.
Okay, we've had one person suggest something. So observing a physical phenomenon. So, for example, using a camera that would detect if something is happening or not. That could be an idea.
That's a good idea. I totally forgot how smart the physics community was. These are really good ideas. I never thought of them. Anyways, these are really good suggestions. Some were true. Well, We'll get there. We'll get to how it's done, as Atomic said, the correct way. But let's start from the start. Okay, I want to since I was talking about how it happens in some Python libraries. Let's start from the start. So I want to use the reference of the random module. You guys must have used the random module somewhere, right? It doesn't really give you, again, it's the name is a bit misleading. It doesn't generate something random, it generates something pseudo random. So here is how the random module does it. Okay, so the random module uses the current Unix timestamp as the seed to generate the output, the random numbers, right? So it's actually, when I found out about it initially, I thought it was pretty smart, but at the same time, I wasn't satisfied by it, because come on, it sounds a bit weak somewhere, right? So fair enough. So it uses the Unix timestamp to seed the random generator, and then it accordingly produces the random numbers. So I want to talk more about how it does it, right? Like give you some brief summary, a brief abstract of how things work in the random module. So it uses an implementation of an algorithm called the Mersenne Questor. So the Mersenne Questor is supposed to generate random numbers. It's a PRNG, which stands for a pseudo random number generator, and it is able to generate a sequence of random numbers when a seed is given to it from the seed itself. And the seed, of course, in this case, is by default. If you don't seed it, you have an option to seed it, but if you don't, then by default it uses that Unix timestamp, and from that seed it generates a sequence of random numbers. These random numbers, the catch here is that even though the algorithm is pretty tough, the thing is that these random numbers would eventually start to repeat itself after a point that you generate from the seed. Okay, and for one given seed, the sequence of random numbers generated are the same. So if you gave this information to someone who is really into cryptography, they'll probably have a heart attack. And because of that, you must have heard people say that, okay, don't use the random module for things which are cryptographically sensitive, right? You must have heard them ask you to specifically use the secrets module. Now, the secrets module is another library provided by Python. You can check out its code base from CPython's official GitHub repository, which is able to generate the random numbers according to itself, which is able to generate cryptographically secure random numbers. So pseudo random numbers. So it's a CSPRNG. But then the question arises: what is so different about the secrets module, right? I mean, it was already pretty smart for the random module to come up with random numbers on its own. But then how does the secrets module come up with these random numbers? Now, again, I didn't give you time because I think I've put the answer somewhere in the slide itself. Okay, I haven't. That's nice. So the secrets module, it uses, I won't go into the depth of how it happens, but I scrolled through the code base. All I would say that it actually uses a class from the random module itself, which is called the system random module, the system random class. The secrets module uses this class, and this class is responsible for fetching the entropy from your operating system. Now, how your operating system comes up with these with the entropy is something that depends on the operating system we're talking about. If we're talking about Unix systems, then it's of course /dev/urandom. If we're talking about Windows, then it's probably some Win32 API, right? For the purposes of finishing up this talk, I want to look into this. I want to look into /dev/urandom. Because I'm more comfortable with Unix systems, and as far as I've understood, when Windows also does the same thing, more or less. So it fetches the entropy from /dev/urandom. Fair enough. But how does /dev/urandom, a file in your Linux system? Well, it's not a file; it's a device. But continuing, a file in your Linux system come up with random numbers, random bytes. You get it, right? How does it come up with this entropy? Again, the answer is in front of you because I put it in the slide. But it's still interesting to think about it, right? Since the answer is already in front of you, I'll brief up more on that. It uses entropy that is generated by a system, and this system and this entropy is generated by so basically every time you move your mouse, every time you use your keyboard, every time a drive is read, all these functions, they take different amounts of time, right? I think someone in the chat also said that we can use some physical hardware, but more or less it happens here, more or less. It's not as smart as you're talking about, but more or less there is something like that which happens here. And all this because of the random entropy, because of the factors involved here, we are able to use this information to as seed, and then we are able to generate an entropy pool, which is then further used for the secrets module, right? So that's pretty much all I wanted to talk about here. But still, before I end this talk, I know this was short, but before I end this talk, all I want to leave you with is the fact that to mimic the most basic of things, something like coming up with random numbers, which you can do on your own at the top of your head, to mimic the most basic of things, we had to come up with algorithms, smart algorithms, and we had to come up with creative ways to get entropy, to get the seeds for our CSP-RNGs, for our PRNGs, just to mimic the most basic of things, which is coming up with something random on your own. So it's almost beautiful how it all comes together and how we try to do these things. That's mostly it. I think my talk, I think I've covered most of it. If you guys have any questions and answers, I'm open to them. But again, as I said, I'm no expert. I am just someone who was very curious about this topic and thought, you know what, I'm going to give my first talk, and it's going to be about this one topic that I loved studying up on. So go ahead, ask me questions. No problem.
We've had a few suggestions in the meantime. One which is a bit recursive, but we'll get to that. Right, observing physical phenomenon such as a coin flip. So using a robot to flip a coin and then observing the coin flip. Okay,
but you cannot do that dude. That's a good suggestion, but usually your computers and your mobile phones don't come with coin flippers.
It's all about getting creative.
Theoretically, if I were to build one, would that work? I don't know. I think you've just inspired my next project.
Okay.
We've right. Are coin flips truly random? I don't know. Someone suggested a kind of recursive approach using a random sample of a random number, which is like,
Okay, yes. So it's like the chicken and the egg. But the random number has to exist first, right?
True. And I had an actual question, less than a suggestion, but you mentioned dev-u random. And would a less powerful computer, let's say a Raspberry Pi or something on a very small device, such as an ESP32, which runs a very lightweight version of Linux, such as what we can see in the IoT world, have a slower generation of entropy than, let's say, an IBM Z mainframe? Like, is there a difference in speed?
Dude, there must be, but legit, I don't know.
That's fine. That's a question that's like, could you, if you knew the device, be able to then generate a slice of random, the entropy values, and then attack based on that?
That seems kind of impossible. I don't know, man. It's a good question that I might have to look into myself. As I said, it's just something that I've studied up on my own for the sake of fulfilling my curiosity. But that's a good question. I don't think it should be possible, but since something like a Raspberry Pi doesn't have these other physical, well, I think it should be. Well, it's something that I have to study up on my own, and I think it should. I think it should be safe enough.
I mean, yeah, it's to have the idea of actually going ahead and like enumerating devu random to then do very like microsecond specific attacks sounds a little bit overkill. But
me and the boys reverse engineering site/dev/urandom.
So yeah. Interesting topic, indeed.
Yeah, and thank you so much for presenting it for us. Honestly, I think that's gotten a lot of people thinking, a lot of brains going, inspired some new projects. Is there anything else you'd like to add, Elliot or Nikos?
Not really. Nothing else. You guys can follow me on my socials. It's everywhere. And you can find me anywhere with my username being 0x0elliot. Other than that, I would like to thank my friends who are just sitting right there in front of me. Wait. So they were like, you know, we will support you through the talk. And they did. So we had to find a room to sit together. So I'm in college right now.
That's amazing. Thank you so much for coming on, and thank you for your time. It was so much appreciated.